Stay hungry, stay foolish.
I want to thank our sponsor Eye, boldly transforming the future of financial services with a suite of embedded products and services, enabling businesses to manage multiple payment workflows and move funds with ease. Check out Eye at hellozai.com. Let's get into Supertrends with Lars Tvede. I thought we'd launch straight into the biotechnological revolution, life as computer technology. And this involves J. Craig Venter, CRISPR-Cas9, monogenic disorders, GM crops, and loads more besides. And having decoded human genes, the development of biology will follow the main trends in the development of computer technology.
The planet is a supercomputer. It's a spontaneous supercomputer. And it became a supercomputer because of RNA and DNA. And that computer is just evolving itself. And then it created us humans, and then we created what we call computers, which is not organic. And then there's a whole culture and ecosystem around that. And we are familiar with that. And certainly we realize that life is also a computer. And then it's pretty difficult to figure out how you crack this. But now we have cracked it, and then what I say is that a lot of the themes and the experiences we have from traditional computing will just be replicated when we now work with life as a computer. And funny enough, a lot of the vocabulary is similar. So we have worms and crawlers in our computers, but we also have in real life and viruses and so on.
One of the big breakthroughs was CRISPR, and we don't need to go into the technical details of CRISPR, but the breakthrough came. It was interesting because you studied, you were saying about agriculture, etc., and understanding how to make cheese. It was during the understanding of yogurt that actually they discovered CRISPR, and they discovered how it would attack and then disassemble other DNA and store it, almost like writing down notes of kind of going, if they attack us again, this is what we're going to do next time. And it was that understanding that was like, okay, what else can we do with this? And I love these accidental discoveries that happen so often when it comes to innovation.
The bacteria that you use for making yogurt, they got attacked by these bacteriophages, and then they just cut them up. They kill them, and then they cut them up. So imagine somebody breaks into your house, and then you say, I kill you, and I cut you off, and I put you in the freezer, so I will not forget how you are. So it's a bit morbid, but that's what they do. And it's a bit like RNA vaccine, where you have this string of code, and you can use that string of code to create anti-stuff in this antibodies in this case. The interesting thing was how clever it was at cutting up the genes. So by doing that, it creates this enzyme called Cas9. So this is this technique has already been approved upon, but it was really something that made a breakthrough, because now gene editing is far safer and far more precise than it was before this technology. And it just means that we can edit genes very, very easily. And before that happened, amazing things had already been done. Craig Venter, he had created a virus from chemicals. So the virus is officially not defined as living things, but they do replicate. So they are close to being living things. So he created that out of chemicals. He managed to take a bacteria and then change it to another species without killing it in the process. So you just take the DNA out, you put another DNA in while it's still existing. So it's a little bit, you remember the movie called The Fly, where this poor guy slowly turns more and more into a fly.
Bits fall off. Yeah. I was telling my kids about it. I probably scared them for life.
So he does like a mild version of that. It's not so appetizing, but you can do a lot. And And then, of course, you start thinking about, okay, what do we want to do? And that's where the more you read about it, the bigger the prospect just seem. I don't know where you want to start.
We'll jump around the place. Let's talk about, for example, the idea of a digital Noah's Ark. So we can store the DNA code of animals that have gone extinct. We can remix them, like you talked about the drum and bass track with a bit of trumpet in it earlier on. We can remix like a track on a mixer. We can designer code and the ethical elements about that. Do we design our code? How do we do it? We can keep pets alive, as you talk about. There's so many places. You just bring it wherever you like.
Now we're within sustainability, and it's true that if we made a physical Noah's Ark and we had two of each, that would not be enough, and also they would eat each other very quickly. So in the end, most species would be gone again. But there are different analog efforts, of course, to preserve threatened species. There are all these seed banks where you have collections of plant seeds and store them in a way so that they last very long. You have zoos that include some animals that are very close to eradication. But from the most fundamental point of view, if we think that we can recreate species as long as we have the DNA sequence, then it is a very big task simply to sequence all DNA of all life. And so the question is, can we, if we have the DNA, can we recreate an extinct species? And the answer to that seems to be yes, we can. So it's pretty complicated though, because it's not enough to have one. I mean, you kind of think that the minimum number of animals in order to have a sustainable population without huge inbreeding issues is maybe 50. So let's say we want to recreate the Tasmanian tiger. What if we need to recreate 50 different ones, and they shouldn't be identical like siblings, and they also have to make sure that there's a natural habitat where they can thrive. So it's certainly much easier to keep species alive to recreate them. But a lot of species have been lost, and the megafauna that was lost was mainly lost at the end of the last ice age because there was massive climate change. Like what we experience now is like tiny compared to what we had there. The sea levels rose 130 meters within a very short span of time. Climate changed, and then the humans then migrated. It opened up the possibility for humans to migrate into new areas. And then you had these big, fat, slow species. And of course, humans killed them. So they killed a lot. But many of them, we have the DNA. So we have frozen samples or other things. So we have the DNA, and you can recreate them in different ways. One is to take a living species that resemble them, and then over a number of generations, just modify the genes so they become more like that other species. Another one is to do like in Jurassic Park, where you actually simply go in and you take an egg, for instance, and then you change the DNA. You simply put in the DNA of something else. And this is like when Craig Venter, he takes one bacteria, change into another one. So that should be technically feasible to do. You do need to have some species that reminds enough of what you're trying to recreate. The problem with dinosaurs, which was in the movie, is that I don't know if we have any DNA that is intact enough to be able to recreate those, but the ones that mainly the mammals that perished about 10,000 years or 12,000 years ago, we can. So that will probably happen, and there are a number of projects underway to do that. Initially just experimentally, but then we will probably see some of these species come back, and some of them might be easier than animals, might be much easier than plants. Yeah, so very important to map all the DNA in the world, and this is well on its way. Craig Venter had a sailboat and was sailing around the world, and then he invited different teams, largely student, on board, and then they were just pumping in seawater and extracting DNA, and they found an enormous amount of new species by just doing that. Very, very simple process. So the other thing we can do, which is exact opposite, is that we can eradicate a species that's called speciescide. So it is actually there are a number of species that are actually extremely difficult to eradicate. So big species, like the ones that disappeared at the end of the last ice age, tend to be very easy to eradicate, but small ones very difficult. Insects and fish and so on. In many cases, the only way you can really do it is by remove entirely the habitats, and then their life stops. But you do have some species that some people say that would be really nice to get rid of them, and there are several. I think there are a couple of thousand different species of mosquitoes, and around 20 of those are responsible for some of the most horrible diseases that exist. So dengue fever, malaria, yellow fever. And so if you could eradicate those, you would still have tons and tons of mosquitoes, but you would not have these diseases, and that would probably make it much easier for areas like Africa and parts of Asia to become more prosperous and much better life quality for the people. So how do you do that? You can introduce a genetic change that is passed on, and then after some generations, it triggers, for instance, that all offspring is of the same sex, female or all male. And when that happens, of course, they cannot replicate anymore. So that seems to work. It's been done in experimental settings, and you introduce that in one simple animal, and then after a while, they're all dead. I mean, it doesn't kill anything, but the replication stops. So yes, we can create new species, and we can eradicate species like that. And of course, we can also modify species, including most radically our own. But the focus here has for a long time been to modify species that we find useful. So almost everything we eat, it does not at all resemble the natural ancestor. And that includes almost all fruits are very, very far removed from what they came from. Carrots, for instance, are nothing. The carrots we buy in a supermarket are nothing like what they came from. Oranges, etc. So what we eat, it tends to be much bigger, much juicier. It lasts longer. It's easier to treat. It's may be more colorful and so on. And this has been for thousands or hundreds of years just a result of selective breeding. And then more recently that we engineered at a digital level. So we go out genetically and very specifically change something which we are conscious about. So it's actually interesting to follow how that has changed, because in the early days, in order to introduce genetic change, people used something called a gene gun. It's the most insane thing almost I've ever heard about in science. So you have these plants and you want to modify their genes. Then you create in a laboratory the gene, and then you have this gun, and you simply shoot the gun at the plant. So you have this genes that are just coming at a very high speed. And most of them, of course, nothing happens. But some of them actually enter some cells and then do the modification. So that's not how anybody does anymore. And also, I would kind of hate somebody shoot a gene gun into me, because I don't know if something would start growing out of me or whatever. So
a carrot growing out of your head.
I can think of worse things also, but yeah. So if we look at the crops in our farms, bigger and bigger part of that is gene modified. and that means that it tends to require less land. And it gives a higher yield. Can also be more useful in different ways. But I think that is only the beginning of something where we really make designer food, where we design almost from scratch what we want. We can also remove things that are impractical. I have several friends who have nut allergy, but to such an extreme degree that it's life-threatening, and they're always carrying injection kit, and they might only have a few minutes to live if, unfortunately, they eat the wrong kind of nut. So you can modify these nuts so they don't create this problem. You can modify cassava so it doesn't have isn't as actually a bit poisonous. You can remove that and so on. But you can also modify food so it tastes great, but it's not unhealthy. So I like a bit beefsteak, but I'm aware that especially the fat part of it is not that good. But if I could have the same taste and the fat would be healthy, that would be nice.
And Harvey Wildbanger flavored steak.
So we can do all of this, and cultured meat, this new technology that is now coming up, is based on genetically modified meat cells or fat cells or similar. And precision fermentation is also modified organisms. And we to grow something, create something by the use of cells is a very old culture, because beer and wine is made in that way, and this is very, very old. And so there we've done analog selection, but now of course genetic selection comes out and becomes more and more efficient. There are now lots of research going on removing the risk of diseases among animals and humans, and also to counteract aging, slow down aging, and even to some degree reverse aging. And I just a couple of days ago I read about all the experiments that are now being done on dogs. So now you have dogs that live substantially longer than normal, and I think many people would think, okay, so it's wonderful you have a dog, you really bond with a dog, but unfortunately it ages so fast, and suddenly it's ill and then it dies. Some people you can clone. I've seen services where you can get a clone of your pet. Not many want that, but I think many would want the pets that live longer. But of course, if they do have that, then after a while, people think, why is it that my dog can live 3 times longer than normal and I can't? I want to be 300 years old, So eventually, I feel convinced that eventually humans will also really start modifying themselves. And you can just say that we do genetic screening of unborn children, and that's now widespread. The first time it came out, many people find it horrifying. We do artificial insemination. We have artificial teeth. We have contact lenses with artificial hips, and there's a very, very, very long list of artificial stuff that people are doing with the body, including stuff that I find like Brazilian butt lift. If you've heard of that, I think no, you remove some of your fat from your stomach and inject it into your butt. So if people are willing to do that, they're willing to do quite a lot. And there have been opinion polls where you ask people the same questions in different parts of the world about the attitude to changing their children, modifying their children. So if, let's say, you could do a genetic check and modification of your children before they're born, and then you ask things like, okay, so if if you find out that your child will have a mortal disease, and you could have a genetic modification to prevent that, would you have it? Then all over the world, the majority say yes. And then that your child will have a disease, it's not mortal, but it will be very inconvenient, will you have it? And the percentage that says yes drops, mainly in the West, so not so much in Asia. But then if you go to, you could genetically modify your child to become more intelligent. Would you do that? Then the majority in most Western nations say, no, that's artificial. But if you go to Asia, there are a number of countries where they say, yeah, of course, I want to have bright children. Yeah, go in and do it. So somewhere eventually, I mean, most of what is possible, if some people find it useful for some purpose, I think it will happen. And then it will become more and more normal.
One of the things I just wanted to highlight was you were talking about, Lars, about how, say, for example, carrots or bananas, that they have been selectively bred over a long period of time. So we've been doing this, just not so overtly with technology. And the other one you gave was, you mentioned dogs there. Like, dogs have evolved essentially to 160 or so species from the grey wolf as well. I thought this was really interesting because if you think about it, it's the same thing as moving from an analog way of doing things to a digital one, and that always brings resistance because it's always so more pronounced and obvious, and it feels like science fiction.
Yeah. So technically, dogs are not species because they can all interbreed, and they can also interbreed with wolves. But you in different and other areas, we have seen human-created speciation, including in mosquitoes. For instance, you have a tube mosquito in UK that specializes in living in the tube, and that can no longer breed with its ancestors. And there are a number of other cases. So humans have actually created a number of species, weirdly. But yeah, so dogs are domesticated wolves. And they're domesticated in the sense that their looks and their behavior is more like wolf puppets. For instance, the ears hanging down instead of standing up is something that puppets have, but grown-up don't have. And their behavior, dogs are super childish. That's a reason why we like them. Wolves are not that childish. They're more cunning. How can I eat you? And the funny thing is that we've done that to ourselves. So modern humans are domesticated previous humans, which were they were far more aggressive, probably more psychopathic than is common today. So we domesticate a lot of things, and this is probably still going on in many different ways.
You mentioned earlier on, and I think it was part 2, we mentioned Aubrey de Grey, and we're living longer, ending aging, hopefully in some ways. And you talk about the advances. Firstly, you touched on this earlier on, but this is highly connected to the whole idea of gene editing and understanding genes, is the advancements in cancer research. And then the other one was stem cell research, because stem cells, understanding them has been a huge advancement in humanity, because now we can, like you were saying, you can get your hip replaced. Now you can actually start to do it with cells, including aged cells.
Yeah, so with the stem cells, there was a Japanese scientist who received the Nobel Prize for discovering how, by making just 4 genetic changes, you can turn any existing cell into a stem cell. And the point of stem cells is that they can, what happens is that you inject them some part in the body, and then they look around and they say, okay, all the cells around me here are muscle cells, so I'll turn into a muscle cells. They're like social creatures. Or they're all bone cells, so I'll turn into a bone cell. So you can use that to do repairs. For instance, the aging brain, you will have a lack of brain cells, and you can then probably increase your intelligence or reverse your intelligence by injecting that. You can repair broken nerves. Like, the worst thing is you fall off a horse and then you can't move most of your body, possibly from the neck and down, and then you can use them to do that, and so on. So you can make artificial intestines, so liver, etc., heart of your own cells. So you can have you can create these molds, and then the cells grow in these molds, and then you actually make these artificial parts, teeth, and so on. So that will also, the repair mechanism for the human body is becoming far more sophisticated because of this. So this is repair, but of course one of the things that concern us is the basic process of aging, and the basic process of aging, apart from wear and tear, is about loss of information. So it is that, we're born with a DNA which has fantastic information about. It's like a recipe for you and me, but as we age, every day there's destruction of DNA in our cells, and lots of it. I mean, really lots and lots of it. The far majority is then repaired, but a little bit is not repaired, and then all these errors accumulate, and in the end we are like, it's like somebody made the recipe, but the cookbook is missing a lot of pages, so it becomes a bit of a mess. So an old person is a bit of a mess, and there are different techniques that can prevent that, slow that down, and so on. And that's also, I mean, one of the worst causes of this loss of information is that there's something called the Hayflick limit, which is after cells have divided a number of times, it won't work anymore. And the reason it won't work is that at the end of each DNA, there's something called telomeres, and that has no useful genetic information. So you lose a part of that every time. In the end, you've lost all your telomeres. Next time it divides, you lose useful genetic information, and then you get in trouble. So the simple solution is to have longer telomeres, and this can be engineered. And we have found that people who are naturally born with longer telomeres, they age slower and they live longer. So yeah, there's a lot on its way in anti-aging. The magic pill doesn't exist yet, but probably will. We did speak a little bit about that in a previous episode, but within 10 or 15 years, there are probably some treatments that can partially, for a period of time, reverse aging and surely slow aging also.
Just one thing on the telomere. There's a book called, I think it's a book called The Telomere Effect, and it was saying actually, if you have a purpose when you're older, if you have a reason to get up every day, your telomeres actually are longer. So it really impacts. It's that whole idea of epigenetics and the biology of belief. It has a dramatic effect on belief, has on telomeres.
Yeah, so genomics is very complicated because of a number of phenomena. One of them is epigenomics. And this is what we're talking about here. That is, if you imagine that your genomes is like a piano, and you can play on the piano, what happens when cells specialize is that a whole number of different, what do you call the things you press on, they get blocked. So in the end, you can only play, a very simple tune.
Yeah.
And that gets blocked in different ways in different cells, and that's all good. I mean, nothing would work if it didn't. But also that the way they get blocked depends on your life, your psychological state. It can even happen before you're born. So if your mother is stressed, you can be born with some things blocked, which will probably in some ways handicap you. And the understanding of this is very demanding because it's incredibly complex. But the combination of scientists and strong computers means that we are moving into this, and we are understanding more and more. And of course, there's a lot to gather from that. And the other thing is that a lot of phenomena are polygenetic, and that means that it's not one thing that creates a symptom, an effect, but it's a combination of a number of things. It's a combination of a number of things that creates cancer, typically. So you also have things that that you could say a difference between two people is due to the position of a single base pair on the DNA, but that's quite rare. Normally, it's very, very complex, so it takes a lot to understand it. But we are getting there. I mean, and the speed at which we understand these things is growing exponentially.
It really makes it very obvious why you're a tech optimist as well. All we'll have time for more today is maybe to share your trend advice on the things like nootropics. I'm pointing over there because I have some stuff, mushrooms and stuff like that over there, that mushroom coffee and the stuff that's supposed to help your cognition. And we're seeing biohacking, we're seeing device IoT, for example, people kind of biohacking and trying to get the best out of themselves particularly in a knowledge economy where your brain is actually your asset, and trying to get your attention better, all this kind of stuff. It's one of the most common questions I have on the show is, how do you read so fast? I'm a terribly slow reader. I'm really slow because I don't just, like, I've sent you my notes. I don't just read, I take extensive notes, and that really slows me down. But it's just, I think it's because of how I attend to reading. It's the way I approach it. And when you're going to be asking questions on it, you read differently, you read in a different way as well, all those type of things. But I thought we'd share as a kind of final piece of advice for people. Maybe it's an entrepreneur out there who has an idea. Maybe it's an investor who wants to invest in a company. What are you seeing in this realm?
What is big now is biotracking. In our venture fund, we invested in Beat, which makes women's jewelry, and it tracks your biometrics, and then it talks with an app. And we have almost 4.5 million paying subscribers right now. So that is super popular.
My wife is one of those 4.5 million. I'll tell her she has to wear it now.
Thank you. It's going public, I think. I don't think we are very far from far more sophisticated biotracking. So I myself, I have several times a year I do a blood test for 200 different things. Once a year I do a full body MRI. So I do quite, and this is fairly expensive and time consuming, but I do this kind of tracking because I think if you find things early, and then you can prevent a lot of disasters. But eventually these things will become much easier to do, and then people will be far more likely to have really sophisticated biotracking, so they can get super early warning about stuff that is about to go awry, and then they can take preventive measures.
Lars, final question for people who want to get onto the next Beat, want to be the next investor there. Where can people find out more about your fund, also about you and all your books that you've written?
LarsTvede.com. So it's just my name.com. About the venture fund I co-founded is NordicEye.com. About the forecasting company I founded is called Supertrends.com, or that is the website. And then I also have a hedge fund, but that's closed for new clients now, but it is called Atlas Global Macro, and we expect to reopen later this year or next year.
Always a pleasure, always mind expanding having chats with you. By the way, we only got to chapter 3, we didn't even get to chapter 4. So we'll have to connect again another time. It's a great book. I really highly recommend it. Really accessible read. Author of Supertrends, 50 Things We Need to Know About the Future. Lars Tvede, thank you for joining us.
Thank you.
I hope you enjoyed, once again, Lars Tvede on the Innovation Show, on the Exponential series, covering his book, Supertrends. Don't forget, there's a copy up for grabs. Just sign up to the innovationshow.io newsletter and you will be in with a chance to win that. As always, thank you to our sponsor, Eye, boldly transforming the future of financial services with a suite of embedded products and services, enabling businesses to manage multiple payment workflows and move funds with ease. Check out Eye at hellozai.com. See you soon.